is really the only truly integrated optical measurement system available today.
For me, it's been very much a dream come true. It's been a revolutionary event and really upgrades my capabilities as a plant manager to control my costs, to control my process, and to really free up my staff to do more important, higher value work.
We have a simple flow-through system. We have a very intense lamp system. We have a very, very good detector. And this is another very good distinction between what we do and what other people do. This system is a high-end detecting system. It's a photon detector. So it actually counts the photons. It's not an analog system. It's not even a digital kind of analog system. It's measuring actual photons and impinge on the detector and counts those, and you get a rate out of that. And that rate is very quantitative, and that allows us to give better answers.
And they asked me, well, what were the 3 most important or valuable parameters that you could develop, or we could develop for this machine? And well, first of all that came to mind was COD. We run COD parameters throughout the plant on a number of different process points to see what's going on very quickly, because we can turn that around in just a few hours. The problem with that test is it's very expensive in the materials and supplies to run that test. So that was an obvious first choice to reduce expense. Another one I was pretty hesitant to bring up at first because it's pretty non-traditional for anything that we're familiar with in the business, and that is BOD, and that's specifically carbonaceous BOD5. And I was hopeful that they wouldn't leave at that point, but they seemed like that was going to be a pretty easy thing to master. And then the third thing that I came up with was E. coli. Takes a long time, and oftentimes you need very quick results on that, or desire to have quick results, but it can take 24 hours. And so with that, they set about tuning their machine and creating their algorithms, their library of formulas to process the data that's generated by the machine. And they very quickly got to the point with total suspended solids and BOD that they were ready to do proficiency testing. And this is third-party proficiency testing that was introduced into the sample stream, and they measured that, come up with a result as compared with the true number as provided by the proficiency test provider, and they nailed it. And we're talking BODs very low, less than 3. In fact, I think the first PT test that we nailed was 2.75, and those digits are significant with this instrument. Typically, if the test runs plus or minus 35%, and if a laboratory can pass a proficiency test and come plus or minus 35% of the actual value or the true value, then you're considered capable of running that test accurately.
The other problem with the traditional, conventional way to do this is that usually it takes a long time. A conventional measurement of biochemical oxygen demand takes 5 days by convention. And so that really gives you kind of a looking through the backward mirror look at the chemistry of the water that you're interested in. You find out what the chemistry was 5 days ago, but 5 days ago the water has already left the plant. So you're kind of always working in the past. So this is why we have to come up with a better technique, and this is why we came up with this methodology. This methodology allows you to make the measurement continually, so you can look at the chemistry that's going on now. So you can adjust your process using this view of the chemistry and make your process better. That's the whole idea here.